All right, I am back to solve quadratics by using square roots, and this time I have a stylus pen, so we'll see if my handwriting looks a little bit better. So number 16 is the first even we're going to do together. So if you notice in these equations versus the ones above, there is only an x squared, or when we get to 20 and 22, there's stuff squared, as I called it in class. So with only the x squared, we want to isolate that first. So I want to get this x squared alone. So the first step to do that is I'm going to subtract 8 from both sides. Stylus doesn't work too great. But I'll subtract 8 from both sides and we'll have 5x squared equals 380. And the next thing we'll do to both sides is divide by 5 to cancel that 5 in front of x squared. So we'll get x squared equals 76 when you divide by 5. And then the only new operation was canceling a square with a square root. So if you square root both sides, we're going to end up with x equals plus or minus square root of 76. But we need to take that extra step and make sure there's no perfect squares in 76. And there is for this one. 76 is 4 times 19. So that's going to simplify to a final solution of plus or minus 2, because the square root of 4 is 2, square root of 19. And again, that's still two solutions, positive 2 root 19 and negative 2 root 19. Those would be two x-intercepts of a graph. They're just not nice. 18 works the same, it's just extra steps. So in 18, to isolate a squared, we'll subtract 2 from both sides first. So that'll leave us with just negative 10a squared equals negative 28. And then we'll divide both sides by negative 10. And we'll get a squared equals 28 over 10 is going to reduce to, I believe, 14 over 5. And then we'll worry about rationalizing that. I just double checked. It is 14 over 5. And then now when we square root both sides, we're going to square root the numerator and the denominator. So I'll switch up my colors here. So if I square root, I'm going to square root the top and the bottom. And what's bad about that is the square root in the bottom. So to get rid of it, we'll multiply by the square root of 5 over the square root of 5. And right now, I don't have a ton of space. But right now we're left with a equals plus or minus 14 times 5 is 70. Square root of 5 times the square root of 5 is the square root of 25, which is just 5. And then I don't think there are any perfect squares in 70. I'm going to check a couple real quick. But I'm pretty sure that's it. Yeah, that's it. So that's rationalized. So that's my final answer. Plus or minus square root of 70 over 5. If you left it as square root of 14 over square root of 5, I mean, that's right. It's just not simplified completely. So you'd probably just lose a half a point. 20 and 22 are still solving by square roots. But if you notice, instead of just a variable squared, we have parentheses squared. But the problem works the same. So I want to isolate now these parentheses squares. So this is what I want to isolate, this stuff in here. So to do that, we're first going to divide both sides by 2. So if I do that, that's going to leave me with n minus 5 still squared. And 18 divided by 2 is 9. And then now I can cancel that square with the square root. So if I square root the left side, that's going to leave me with n minus 5. If I square root 9, the square root of 9 is 3, so that leaves me with plus or minus 3. And then now when I add 5, I'm going to have to add it to 3 and to negative 3. So it's going to give me two different answers. So n is going to equal positive 3 plus 5. That gives me 8. And n is also going to equal negative 3 plus 5, which is 2. So I get 2 solutions. They happen to be nice. It's not always the case. So in 22, I think it's not going to be so nice. So in 22, again, I want to isolate this stuff squared. Everything in these parentheses here. So to do that, we'll add 5 to both sides. So I have x plus 1 squared equals 78 plus 5 is 83. And then we'll square root both sides. So the square root's going to cancel the square on the left and leave me with x plus 1. On the right, it's going to be plus or minus square root of 83. And I'm pretty sure there's no perfect square in 83. And then we'll subtract 1 from both sides. And just because of proper notation, that minus 1 will go in front of the plus or minus. If there was a perfect square in 83, we would have simplified it out. But since there's not, we're just going to leave it. So that's our final answer. The last one on review number 1, it's an odd, but I'm going to do it anyway. So if you just copy it and kind of follow along on your version, that's fine. We did some of these in class one day when we had a weird little station set up, so it should look familiar. Here we have a rectangular garden that measures 42 by 8 feet. Let me draw a picture. Here's my garden. It's 42 by 8. Oops, not 48. We want to double the area by expanding the length and width as shown. I'll give you a picture. That's why I'm giving you one now. So we're going to add some amount x, keyword add, some amount x to double the original area. So area is length times width. So the new length is going to be, it was 42, but we're adding x. So the new length is going to be x plus 42. The new width is going to be x plus 8. And the new area is twice the old area, so that's 2 times 42 by 8. And because I don't have a lot of space, I'm just going to erase this, so I'll wait a second and explain a little more while you write. So you kind of see we have a quadratic on the left side, and on the right side we're going to have a number, but to factor and to solve, we need that equal to 0. So I'm going to end up multiplying all this out, and I'll kind of do it step by step. So I'm going to start by the 2 times 48 times 8, or sorry, 42 times 8. If I multiply that out, it gives me 672. That's twice the original area. And if I FOIL the left side, that's going to give me x squared plus 8x plus 42x plus, let me make sure, 336. Oops. And the problem here is it's not equal to 0, so on the left side, I'm going to combine these like terms. I'm going to combine 8x and 42x, and I'm going to subtract the 672 on the right to move it over to the left. So I'm going to erase a bunch here and kind of write what I come up with. So pause the video if you need to. So when you FOIL, combine like terms, and subtract the 672, we end up with x squared plus 50x minus 336 equals 0, and I have to factor this just like we factored at the very top. Luckily, x and x come first. And then we need two numbers that multiply They have to multiply to negative 336, and they have to add to 50x. And it took me a couple guessing and checks to figure it out. I got those winners are going to be minus 6 and plus 56. And then we continue on, that's 56, by setting these equal to 0, both of them. So for the left factor, I get x equals 6. And the right factor, x equals negative 56. And if you remember from class, when we did those stations, the negative here doesn't make sense because it's real world. So the solution, how much they should add to double the area of the garden is they should add, I think it was in feet, 6 feet to double the area of the garden. Good luck doing the odd problems. Make sure you turn in the odds and the evens so you can copy the evens as you watch the videos and then just do the odds on your own. Thanks, guys.